Hey, is that Brian's car?
It doesn't get any bigger than this build. This is the Brian Kinwald RC10. It's the one we've all been waiting for, so stick around. This is the most faithful commercially available re-release of Brian Kinwald's IFMAR winning World Championship buggy from 1993. And it includes some of those iconic parts that he modified himself or commissioned to have done, including the chassis, which is shaved, the battery brace, the front shock tower in carbon fiber, the carbon fiber transmission brace, the iridium rear shock tower, and the shaved nose piece. Don't forget the motor plate, and that one is shaved and milled. I can't wait to get these parts together, so let's get at it.
These are some of the last pictures of Brian's car before it was stolen, just a few races after the 1993 IFMAR World Championships. A big thank you to RC10 Talk for putting out two very detailed videos that are the blueprint for adding those extra special little pieces to this already really good team-associated base kit. We're going to add some of those to this car. We're going to pick and choose. We're not going to try to do everything. You could really go crazy with this. And I don't think you're going to get to the final solution in one iteration with this build. It just depends how far you want to take it. If you want to go all the way, I've posted the links to those two videos in the description below, so check it out. As usual, Team Associated has beautiful cover art on the manual, but what really counts is what's on the inside, so we'll see how it goes. Here's the nose piece with the shaved sides, and they're really nicely done with very highly polished edges. But you'll notice that this is shaved on the backside also, and that's something that Brian did. But that surface should not have anodize on it. It should be silver. We're going to countersink these nose tube fastener holes because Brian used flathead screws on almost everything. But first, let's sand off that anodize on this shaved side, which now the parts are made that way, so they get plated, but we want this to be authentic. So we're going to round out that curve right there, and that's already looking pretty good. And then we want to get this edge here. There's not a crisp line as to where the black should start, so you'll just have to feather it in as best you can. But I think that's going to be fine. It's going to be hidden. And then we'll go to 1,000 grit sandpaper to get a little smoother, and then 1,500. Keep polishing that out a little bit and try to get close to the factory look. The surface isn't going to be identical because the factory used a machine tool to make that. But that looks pretty good. I'm really happy with that. And that little detail, it's just fun. Okay, now we're going to go in and countersink these holes. So I'm going to take it to the drill press, and voila. And there they go. And the screws should sit pretty flush, so go deep enough. That looks awesome. Okay, now if there's one thing you should upgrade to, only one thing, it should be the aluminum pan screws. Okay, K&K Hardware makes these, and they're beautiful. They come in two colors, light gold and dark gold. This car takes the dark gold. It's really not very dark. It's more green. Brian had custom body mounts made for his car, and that's one thing that I'm not doing right off. You're going to either have to 3D print them or have them made in a machine shop. They're black. You'll see them in some of the pictures. Now, the chassis is gorgeous. It has the shaved side rails. They come down at an angle from the front to clear the nose tube holes, and the rear has that beautiful curve on it. Those two countersunk holes should have the ano removed if you want to be super authentic, but they, of course, are going to be covered up by fasteners. I'm putting 1/2-inch long screws in all three holes. Why? Because that's the way Brian did it. Is that because he lost his short screw for that third hole, or he thought it might rattle out, or what? We don't know, but he did it, so I'm doing it. Now, you're going to have to torque these down quite well because the cone of the fasteners hit the thread on the nose piece. I think these chassis might be a little bit thinner than they used to be, and they're countersinking them a little too deeply. So tighten it down and it will snug up. You can see these gold screws poking through various components on Brian's car, so you know that he used them. Here's the first time I've seen black World's Car bell cranks. Thank you, Team Associated, for issuing those properly. And as you'll see, that is what was on Brian's car, and he used black ball cups, and I see a little brass ring under the ball stud. I didn't do that here. I'm missing that, but I'm going to have to go back and maybe add that. So it's those little touches that you can spend a lot of time with on this car, and put it together the best you can the first time, and then you can keep tweaking it as you go. This kit comes with these nice ball bearings for the bell cranks, and they are going to turn really nicely here once we get everything together. We'll just slide our nuts through, and then these little rings sit on the bottom. Now, ideally, they fit slightly tightly so the ring will stay on while you tighten the nut up, and it won't fall off, because you need that centering ring to stay over the nut and not get off to the side. Otherwise, it's going to bind or not tighten all the way down. So just make sure that that doesn't fall out of place. This side was not as tight for me, so I had to be more careful with it, and I sort of tilted the whole chassis so that it would stay on the center there. You could see it popped off pretty easily, but I did get it, and just look at it and make sure that it's all in place. And then everything should turn really smoothly. And unlike the four-wheel drive, the ball studs are not rubbing on the nose piece. Everything clears. Here is our front shock tower with just 2 holes on the top. No adjustments. Brian knew where he wanted those. The screws slide right through, as is common on the later shock towers, whereas the originals, the screw was tight fit and you had to thread it all the way through. But this is easy for switching parts out or changing positions, but there's no position to change. Just use Loctite or these will come loose on you. Brian had some special fasteners for his ball studs that involved a blue anodized ring and some other hardware for the nut. I haven't tried to track that down yet, so here I'm just going with the kit spec hex nut. More things to do in the future. These are the correct arm mounts. They were white on Brian's car. They are marked left and right. And there you can see that most of the plastic on Brian's car was black, including the arms and the caster blocks and the steering arms. But these arm mounts were natural. So really cool that Team Associated has got almost all of the plastic colors right on this kit. Really saves the purist a lot of trouble in switching out parts. But there are some things we'll change, as you'll see. So here we're going to put in our pan screws, and there's 6 of these. So it does help to have a comfortable screwdriver or a power tool, but be careful and don't put too much torque on these, as you might either damage the plastic or strip out the head of these Phillips screws. But I enjoy this, and okay, that's just me, but it just brings back memories. That's the way it was as a kid, and you can see the fasteners sticking to the arm mounts. I love that. That's the right color. I've never seen a picture of the bottom of Brian's car, but I think this is the way it would have looked. Next, we're going to put some blue anodized spacers below the ball studs on the steering arms, because that's the way Brian had it. And you can see that here in this picture, sneaky little view underneath the ball cup there. And I think this is going to replicate it pretty closely. There's not a lot of meat in these arms, so you definitely want to have a keeper nut on the bottom. But in this case, it's just a standard hex, so you're definitely going to want to use Loctite there. And that's a good looking assembly. That little piece of blue there. Now, I've said previously that I don't think this blue ano looks period correct, but apparently it was starting to come into favor right around this time in '93. So, hey, I'm getting with the times here. And here are our black caster blocks, and again, with the ball studs. These are also retained with hex nuts on the backside. So same drill here, but there's a little more fat to the plastic that the ball stud goes through on this one. So it should be nice and secure. Now, again, it's nice that these are the correct colors. Here, let's put our on-center axles in here. The kingpin goes right through the axle. And there's a set screw that locks into the kingpin that keeps it turning with the steering arm. And we'll put some Loctite on there, which will get used in a moment when we tighten it down. And if you've watched some of my other videos, you'll know that I typically replace these E-clips with the phosphate-coated ones that are more of a black color because that's what the cars had at the time, and no exception here with Brian's car. This is a really minor thing, so I wouldn't feel bad if you go ahead and use the kit E-clips. That's fine. Now, as I put the kingpin through, it's got to line up with the hole in the axle and everything, but they go pretty easily. I do feel some resistance here. Not much, just a little bit. And I don't see anything touching on the side, so it must be the top and the bottom of the steering arm. And so I'm just going to remove a very little amount of material with some sandpaper here, and it doesn't take much at all. And now this will go together and everything's going to be nice and free. So you don't want to do too much because then you're just going to add clearance there that will cause excess movement that you don't want. But that was perfect. Yeah, I mean, it'd be nice if you didn't have to do that, but that was a pretty minor fix, easy fix. Now we're going to tighten up the set screw on the kingpin, and we've got our steering arm assembly, and that looks good. Don't go too coarse on the sanding. I use 1000 grit. I like these arms, and this time they're in black, unlike the team car, which came white in the recent re-release. Put on your first E-clip before you install the hinge pin, and it'll be easier, and then you'll have a stop. And then we'll slide this through, which goes pretty easily. I've got to say this whole kit goes together quite well. And I don't recall too many issues as I'm reliving this, but we'll call them out as they come up. I'll put the links to most of the parts that I'm using on this car in the description, so check that out. And now we'll put the main hinge pins on our arms, and we'll feed those in from the outside. Just turn that E-clip so it slides past the nose piece, and then we'll get the back side on here. Brian had a unique way to retain these hinge pins. He put a set screw through the arm mount, which you could see in that picture. That would allow him to run without the E-clips. Those are known to sometimes pop off, particularly the trailing edge, or maybe it was easier for him to switch things out and he didn't like dealing with E-clips. I don't know. But anyway, we're not doing that mod for now, but maybe in the future. And that looks good. Now onto the stealth transmission. Don't lose any of those balls because you don't get any extra. We're going to add some lube to the outdrives where the diff rings sit so that they'll be retained a little bit and not flop off. So we're going to use this diff lube that comes with the kit. I don't really like this lube. It's kind of gummy, and so it works fine for this, but I'll switch over to some of my own diff lube when we go to the balls. So now we're going to do the thrust bearing. And this is what we've seen in the previous kits. Make sure that the groove is up, and we'll use black grease on these parts to make sure they're lubricated. This is the second gen stealth transmission that we're going to be building. As you'll see, there's some differences with the stealth transmissions that have come with the recent re-release kits. It is interestingly the same type of stealth transmission that came with the 2014 Worlds car. It doesn't seem to have the in-play problem in the diff assembly, so you shouldn't have to shim it, which is nice. Now here is our diff gear. Those sort of larger bumps are going to go down, and I'm going to use this diff lube. And the balls will sit down in these cups. They don't need to be on the diff rings to sit there, which is nice. So just take your time and don't bounce any of these across the room. These are not magnetic, so that's not going to work. But I got them all in there. So now we'll add some diff lube on each ball, very carefully, not to pull the balls back out. And this will then serve as our primary lubricant. And now we will start to assemble this diff unit, and we'll put our adjusting screw through the outdrive and put our two bearings in. One of the bearings sticks out a little bit, and the diff gear rides on that bearing, so that's normal. It doesn't drop all the way in. And so now we're going to put this very gently down on the assembly so that none of the balls pop out. And then once we get the other outdrive on here, then everything's retained and we can breathe a sigh of relief. Now we're going to break in our spring, as the manual says to do, and use our little T-nut there that has an overmolded nut inside of it. Now, when you tighten this all the way down, the ears on that T-nut should get all the way to the base. Now we'll make sure it's all the way tight and take it back a quarter turn, and it should feel smooth, which this does. This is a really nice little diff assembly. It's compact, it's really precise, it just feels like a Swiss watch. Don't forget the cover on the second side. We'll slide that in place, and we're done with the diff assembly. So now we'll go on to the idler gear, which has a little plastic sprue inside of it. So we need to cut that out. This is the first obvious difference between the Gen 1 and the Gen 2 Stealth. In the Gen 1, the shaft is overmolded inside this spur gear, and now on the Gen 2, we're going to put ball bearings in here. So instead of the shaft spinning, only these ball bearings spin, and then the shaft goes through the ball bearings. There's no ball bearings in the outside of the case. So, interesting difference there. Now we're going to lube up the gears themselves, and we'll put a fairly liberal amount. Now, one thing these Gen 2, at least re-release Stealth transmissions are known for is being a little tight out of the box. And this one's no exception. This one goes together almost exactly like my 2014 World's transmission went together. Now, I've heard others say that that's true, and some believe that that's an issue. Others say it'll loosen right up once you start running it. Now, here's the transmission case, and it's black, which is cool. That's the first of those I've seen. So we'll put our diff bearings in place. I should have put this bearing in the transmission and then dropped the diff into the transmission. Instead, I push it in. The difference is now I'm loading the ball bearings instead of pushing on the outer race with my fingers. All right, and this goes in. That shaft just pushes in. And then the top gear, same thing there. All right, that looks good. It's a cool looking unit, and really pretty much a modern transmission. So now I'm going to push these bearings in the other side. There's something really enjoyable about pushing the two halves of these cases together and seeing it all made up. I just love doing that. Okay, now, that feels just a little bit tight, as I said. I think it would run in. So you can check that out. Okay, now for this beautiful motor plate, which look how closely that resembles the original, even with that curved cutout shaving there. That's just gorgeous. Now, the kit comes with standard carbon steel black oxide screws for the transmission case, but I'm going with these aluminum. I don't know for sure that Brian used these, but I think he would have. I know they were a silver color, and we're also going to go with the felt gasket because you can clearly see that on Brian's car, but it does not come in the kit. So that's an upgrade for the kit. Now, for some reason, my felt gasket is more brown color than gray. I don't know why. It looks like the outside has discolored and the inside's still a little bit more gray. Anyway, that's just the way it is. So this is fairly thick, so you're going to have to compress it a bit and get these screws to go through. Be careful not to cross-thread these aluminum screws into the aluminum threads in that motor plate. That would be very sad. So get it lined up and gently start to turn. Make sure it goes smoothly, no resistance, and then just work it around. Once you have two in, then the rest will go. Don't over-tighten these screws. We've got aluminum on aluminum, and this is just a plastic case. So if you do over-tighten these, you can crush the case a little and make the transmission even tighter. Now on to the V2 slipper. This is not what Brian had on his car. He used a Hydra drive, which was a fluid coupling, and these are friction discs, obviously. But this is a real nice unit with the Octalock, double pads, and it goes together really well. These discs lock in place really positively. Again, this is the first time we've seen the V2 slipper on a re-release, I believe, since the 2014 World's car. This little hat washer goes in as shown there, so it retains the spring. And we're going to tighten this nut down. We'll need something to prevent the outdrives from spinning. So I'm going to use a couple hex wrenches here. And then I'll tighten this nut down until there's 2.5 millimeter, I believe the manual says, sticking out. But that's just a starting point, and then we'll go from there. Boy, that looks good. I'm just going to say that felt has some dirt on it. Up next, the Iridium rear shock tower, again with only one hole for the upper shock mounts. The mounting holes are countersunk, as Brian's car had. The upper shock mount should also be countersunk and come with countersunk hardware, but the kit does not. Something to upgrade in the future. I didn't get that on this iteration, but like I said, this is the kit that keeps on giving because you can just keep making it better. So maybe we'll do that later, but for right now, we're going with it. Couple points on this bulkhead. These outer mounting points for the ball studs should not be there. And later bulkheads had those removed. And there should also be a hole in between the inner one and the outer. So I went ahead and shaved that off. Brian additionally scalloped the sides and removed almost all the extra material. So this is not a faithful representation of what he did. But I wanted to start with this and then go from there. So we're going to sand the ends a little bit, clean them up. At least I'm happy that those big wings aren't hanging off the sides. So it's a step in the right direction. And then I'm going to put just a little bit of diff lube on those sides to make them kind of disappear. So unfortunately, that hole's not in between. And again, on this iteration, I decided not to drill it. The supplied turnbuckles are actually appropriate for that middle hole, and they're a little bit short for this inner one, although this is what it says to do in the kit. So it's almost like they thought that they would have the other bulkhead with the hole, and they didn't, and then the turnbuckles were still the same. I don't know. But anyway, if you want to switch over, they will work. Brian used all stainless steel hardware, so we're going to ditch this kit hardware and switch to this 18/8 stainless. You can also get these in 316. They're a little more expensive. They're more corrosion resistant. I didn't think that mattered. It's a subtle change, but another fun little upgrade. So I don't know why I put all these screws in the holes first. I was just so excited to get them onto the Iridium shock tower that I put them in first. I should have put the shock tower on the bulkhead and then put them in one at a time, but okay, it worked out. And then we'll snug them all up. And the kit just shows one length screw on all of these, so I didn't bother to buy two different size of these flathead screws, but one of them does stick through just a little bit further. You can see on the bottom. Time to put the bulkhead in the chassis. So we'll get our aluminum pan screws out and drop this in place. Nothing to this except a nice sense of accomplishment, seeing major components go onto the chassis. And we'll just snug these up and then move on to our side fasteners. And again, the kit comes with standard hardware. We're going with the blue anodized aluminum 5/8 inch long 440 screws. And you will see that that is what Brian ran. And he had blue different places on his car, but you can definitely see it there in the pictures. And so another really fun upgrade. Looks good. Again, I'm becoming a convert to blue anodized parts on these vintage buggies. You can see here the stainless steel fasteners on the shock tower next to the blue hardware. I attempted to countersink the main mounting holes on this trans brace, and I had trouble with it. It dulled out my tool really fast. The carbon fiber is hard and abrasive. So I needed a sharper tool or multiple tools, and the holes are really close to the edge, so if you go too hard, too fast, you can chip. Anyway, here goes the transmission onto the pan, and we've got multiple mounting points. Let's get our screws in the bottom. Again, we're going to go with the stainless steel flathead screws. That's going to give this car just a unique look compared to everything else that I've built and pop against this black chassis. So we'll get these started and then I'll leave them loose because we need to put the other screws in, particularly the two rear screws that hold the motor plate to the chassis. So we'll just get these in 3/4 of the way or more and then be able to move things a little bit to align the rear end. And that takes some doing, and it is all aluminum. But first, we'll drop our trans mount in place. And you can see Brian did countersink these screws. So I've tried to replicate that. Again, a little bit challenging. And I might give that another go in the future. I'd have to buy another trans plate and start over because I've got a little bit of damage going on this one. But it's okay. It really doesn't show. All right, now here we got to match up the holes. There should be no anodize on the countersinking there because Brian would have done that himself. And these are little 1/4-inch flathead screws. And we'll get those started, make sure they go. Now, Brian had a third hole in the middle for kind of bending this around and mounting it in different locations. So if you're a purist and you want to have a perfect replica, you're going to have to put that third hole in there. So look at the pictures for that. But I'm happy. Everything lines up and the curve really matches nicely. Now we'll go ahead and tighten up our trans brace. And the countersinking is not perfect, but I'll live with it for now. And then I like to use an L-arm on these bottom fasteners because they're kind of tight and it gives me more leverage, and you can torque them down with that appropriately, and also get our rear mounts. You should use some Loctite on those rear 2 screws. Moving on to the rear arm mounts. We'll get our hinge pins going with our E-clip on the first side, and we'll pop things together. Now we can slide this through, and what we're going to see is that there's a little axial or end play between the mount and the arm, and I'm going to go ahead and shim that because I'm pretty sure that Brian would have. So I've got some 1/8-inch shims. I'm going to drop one shim. It's a 10 thou or so shim here on the end, and then just keep it on the pin and work the arm in, and now we're going to be in good shape. That feels better. So definitely not necessary, but again, I have those. It's a handy thing to have for these cars, are those 1/8-inch shims. And we'll pop the other E-clip in here, and now we're ready to mount. And we'll do the same thing on the other side because it needs it as well. This is a lot easier to do off the car than on, so I'm glad that I spotted it here and that we can take care of it. And then we'll put the car together. The manual says to build the short wheelbase version, so that's what we'll do here. And that means moving the arm mount to the forward position, and you use the rear 2 holes. And we'll get one started and the other started, and then work them down. It may be that I'm so used to these RC10 builds, but I didn't notice any real problems with the instruction manual on this kit. And everything went together easily. I didn't see any screws that were called out the wrong lengths or any steps that were missed and things like that. So I thought this was generally a better manual. Now, our arms are on, so it's time to move to our CVDs. And we'll start with this little set screw that we need to put some Loctite on so that we can put them on our pins here. And then we're going to need to lube up the CVD joint. So we'll get the black grease inside there and then push the pin through. I put the set screw on the outside so it doesn't get grease in it when you push this through because we got Loctite in there. A little messy. But the actual hinge pins go through easier than you might think. It seems like it's not too hard to find the hole. Everything slides through. Then put your retainer on the outside, put the slit in between where the pins are, and you're good to go. The original 2014 manual, I think, said to glue those retainer ends a little bit so that they don't pop out. This manual doesn't say that. And then we are ready to assemble our hub carriers. So we'll put 3 shims, and then we will go with our bearing, and I should have pushed that into the hub carrier. So now I will do that kind of after the fact. And don't forget this crush tube, that's critical, the outside bearing. And finally, this blue anodized backing plate, which really makes a lot of sense on this car. It's conical. Put the conical side toward the bearing. and then we'll put our roll pin in. These are different. If you notice, these have a slit in them, and they kind of crush when you push them through the hole, unlike the hinge pins for the CVD itself, so don't get them mixed up. I find the best way to do this for me is with channel lock pliers, and just orient them as you see and press them through slowly, and then move the one side off where the hole is so it can slide past the head of the tool. I don't know if Brian's car had the blue, but it matches. All right, now onto our ball studs in the hub carriers, and they will have a backing nut. Now, Brian used a blue anodized aluminum backing nut. I did not get those. I'm not sure exactly what the proper type is to match what he did. I do see some that are available, but they have black nylon inserts. They don't look quite right to me, and they're kind of thick, so I don't know. I'll study up on that a little more before I go ahead and do that. But we'll drop these into place and do our E-clips as usual. I believe Brian's car had the stepped 1/4-inch axles and more of a bell-style CVD shape, so he wouldn't have had that blue backing plate that's on there. But I like the 3/16 axles, and that's the wheel standard I'm on, so I'm going to stick with it for now. All right, we'll just pop this other E-clip on and then get our dog bones in place. These will definitely fall out before I get the camber links on. Now, I'm going with the Fan RC ball cups. I highly recommend these. They go on the turnbuckles with just the right amount of resistance, and they pop on nicely, and they really adjust well on the car. You don't have to worry about them popping off when you're doing your adjustments. So I like to stay with AE on everything, but these are just too good, and I don't want to struggle with the kit ball cups. So there we go. Now make sure you get your mark on the left side. That's your left-hand thread. Put those on the left, and then pop these on, and they look good. They look right. Nobody's going to really notice that they're different unless they have a very discerning eye. Fan RC offers these in black and white. Brian's car used mostly white except for the servo linkage. So if you have to have that, you might have to buy both types. Now, we'll watch how this dog bone engagement is on this kit. On all of the previous kits, we've had trouble with that being too far out. All right, here's the center link. Now, when you put these on, don't push down on your bell crank bearings. You will Brinell the bearings. So run this over to the side and use needle nose pliers to pop this on so you don't load your bearings. I've learned that the hard way, and then everything will go clunk, and you won't like it anymore, and then you'll have to buy more bearings. So do that on both sides, pop it on, and then our center link's in place. And this is turning really smoothly. So again, keep your left hand on the left. We'll put on our upper camber link here, and that looks good. Same on the other side, left is left. And then we will put our steering linkage on. Now again, use the needle nose pliers there on this one. You might be able to push it on with your fingers or use the tool. And finally, we'll finish up here. And this is really enjoyable, especially with these ball cups. Now look at the articulation. Everything is smooth. I can't emphasize enough. This all feels really good. I'm super happy with that. All right. Now we've got a car. This is starting to look like a real buggy here, and enjoying those special changes and upgrades that we're making. The shocks on this car go together pretty much like we've seen on previous kits until we get to the plastics. We'll see there's some changes that I'm making. We'll use a number 1 piston on the rear shocks and number 2 on the front. And I'm just using the standard E-clips on this. You know, they're going inside, so I don't think anybody's going to see that. So there's the number 2 going on the front, and then we'll use some slime here on our seal package. And again, these are just like we've done before with our O-rings and our spacers. Get that last spacer in there, and then we'll have the click. And that looks good inside here. I really like how these go together. And click. So easy enough, and then we'll be able to push our pistons through, but first we'll put spacers. Now, I fooled around a lot on the spacing, the internal spacing on these, because I've had to add in the previous kits. So here I'm going to cut some fuel tubing, 1/4 inch, and make 2 pieces here because I thought for sure I'd have to get 1/2 inch spacing in here. That is what I've been using. So I cut that out, I put a 1/2 inch on, and now I'm going to push this through the rear shock. You don't need anything on the front. Now here's the plastic package. The front shocks take all black plastic and the rears take white on Brian's car. Now here, I'm usually used to using the short rod ends, but I'm wondering if maybe the longs will be better on this car. I haven't figured that out completely yet. Maybe I'll still do that. But the droop on the rear will be a little less than the front with those shorter rod ends and the spacing I'm putting in. So I may change both of those things. Anyway, check it out for yourself. But here I've got the short rod end, and I'm going to put that on this rear shock, and then I'm going to test out the engagement of the dog bone. And what I'm going to find is it's excessively inside the limit here. So I don't need to be that far in because it's limiting my shock travel or my suspension travel too much. So I'm going to take that back out, and here I left 2 spacers in. So I've got like 3/8 of an inch spacing now. And that actually is maybe still too much. I should have just gone with the kit. You can see how much engagement I have there. Now, that'd be great for driving in the sense that you wouldn't get a dog bone popping out, but I don't think it's totally necessary. So, yeah, 3/8 of an inch, probably too much. I'd just say go with the kit recommendation. Now, I do like the fuel line because when you pull the piston out, you don't get all those washers falling out inside the shock body. So I do think that that's a nice thing to do. I'll probably just leave the fuel tubing. Now, we need to ream out the holes for the bleeder caps because the holes are too small. They measure about 62 thousandths of an inch, and the screw is like 82 or 85 thousandths. That's a lot of interference, particularly to get started. So I'm going to use a 5/64 drill bit, which measures 0.78. And I'm going to just take out some of the material. I'm not going to go all the way through. Don't use a power tool on this. You'll take out too much material, but I just want to get started. So now the screw will get going and then lock into the smaller diameter and then tighten it all the way down so you get your threading in there and you'll be good to go. You don't want to be messing around with this when the fluid is oozing out and you're trying to finish up your bleed. But now you'll be good. The kit comes with 30 weight shock oil, so we'll go with that and fill up our body and then work the piston up and down to release all that trapped air. And then we'll let the bubbles float to the surface for a while so that when we put this together, it'll look pretty clear like that. And add some fluid to the cap. It's okay to have some excess here. We're going to push it all out through that bleeder vent, which is a really nice upgrade on this car. That is a difference to previous cars that I didn't call out, which is the bleeder cap. And now we can get this really air-free. So then we'll put our bleeder cap screw in, and we'll be good to go and just clean up the rest of that oil that oozed out. That feels really good. And honestly, with the bleeder caps, I think that's a better feeling than generally any other shocks of this type. So we'll put our black hardware on our front shocks and blue anodized screws. And this is a different length than the bulkhead screws, unfortunately. These are 3/8, but I think this is a really cool touch. So there it is on Brian's car there. I couldn't resist doing this. This is one of the more prominent changes. So the black plastic on the front shock package and the blue anodized screw really pops here. So, and he put these screws on the inside, you'll see, and I'm putting the bleeder cap on the inside. So that feels good. And again, no air. On the rears, he's got all white plastic and silver screws. Now, were those screws aluminum? I'm guessing they probably were. I'm not sure, but it makes sense. The front were aluminum, so why wouldn't he go aluminum on the rears? Here's the correct green springs. Those come with a kit, so big thumbs up on that. You don't have to go on try to source those because those are really hard, have been really hard to get. I guess they'll be more available now. I'm going to adjust the collar in just a little bit to get the right look. Not setting the car up, obviously. That feels really good. All right, there's our shocks, and now we get to install. And there's a nylon lock nut that's going to attach on our top shock mounting point. And we're going to put our blue screws on the inside. Big thumbs up to AE for giving us the nylon lock nuts there, so we don't have to go source those. Brian would have wanted to reduce weight up high on the car, so going with plastic there really makes sense, and they don't need to be super strong. We're going with the outside holes here on the lower arms. These screws should be silver, and they do look like they may be flathead screws that he put in here, and I don't know if he additionally countersunk the holes in the arms. Probably did. We're going kit for the moment, but something else we can change later. That's feeling really good. So we'll do the same thing on the other side and enjoying some of these unique components like this lock nut. And make sure we'll get those all the way tight, but not too tight. There's no pivot ball on the top, so the shock doesn't really rotate. It's pretty much locked in place. That feels super good, and the steering feels good. I'm really happy with that. That you can imagine going out on the track with. And this really looks good, and it's unique. So starting to see the fruits of our labor. So let's put on the rear shocks now. We're going to go white. Now notice that the screw faces toward the back of the car, but on the outside. So yeah, just trying to get the details right. I notice there's not a lot, again, these don't pivot at the top. When I said they don't pivot, obviously they rotate around the screw, but they don't pivot side to side. So the manual says to put those two washers in there, but it doesn't want to take those two washers. So I'm not going to force them in. I'm just going to go with it as is, and I'll just drive this lower through here. Now, Brian used a silver screw there, but I think it was a cap screw, not a flathead in that position. Okay, now our dog bone engagement's good, so we'll go on to the other side and make sure we get everything lined up. I'm using a ball end hex there. That makes that easier on the bottom. Looking good. Time for the nose tubes. Now, I noticed something here after the fact that I should have done. I should cut that section of nose tube behind this screw that I'm going to install to match Brian's car, and it's really a waste. I don't know why they made the tube that long. It continues on back. Maybe it creates some structural side-to-side strength, pushing on the sidewall of the pan. I don't know. But anyway, Brian took it out. Here go the flathead screws in the nose piece. That looks awesome. Been waiting for that. That paid off, finally. We did that early on. And here you can see how much of the nose tube continues behind that screw. You'll see that that gets in the way of our servo mount in a little while. So onto the second side, just line those up carefully. That looks good. And getting down to brass tacks, antenna mount. Brian modified this mount even by putting an angle on it and removing these flanges. So we're going to do that. And the battery cup, he cut most of it down. And so here we go. I dremeled off the angle there, and I need to clean out the hole now after I dremeled that. And then I also removed those flanges, but I'm going to smooth those out with a little sandpaper. And since that flange is sort of in the middle of a diameter, it's a little bit more difficult to remove than it might be otherwise. So I'm just going to try to smooth it out, and then I'll use some Novus #1 plastic cleaner to get all the grit and dirt off that, and then it shines up pretty nicely. So the battery box is cut, and that looks pretty good. I'll just clean up the ends here a little bit, some 600 grit, and then move on to 1000, and just smooth everything off and then wipe it up. Okay, here's where the manual's not quite right. It shows the antenna mount in the front. It should be in the back hole where the countersink is, right there. So we'll go with that. We'll use our nice stainless steel fastener on the pan. and then tighten this down with the angle kind of aerodynamically toward the front. Of course, it's inside the body, so a little bit of weight reduction. Next, for the battery cup, we'll slide that in place like we normally would, except there's a big chunk missing. And just line up the holes on the pan. Again, use the stainless steel flathead screws. And voila, our battery cup is mounted. We're going to get deep into the custom mods now. I'm taking this vintage servo. I trimmed off the flanges, and I'm going to use double-sided tape to attach to the chassis. I don't have anything special in terms of servo horn, but I'm going to use black vintage ball cups that I had. Fun to use period pieces when you can. You can see Brian's car there with the servo. Notice that it misses the nose tube because the nose tube's cut shorter. But anyway, we'll get this in here. I'm pretty happy with the way it went in initially, but I think I could get it a little better. Brian's servo horn is more of a flat design, but this is a 25 spline for the Futaba servo, and it works well. The screw was conveniently still on this servo, so I didn't have to hunt for that. And now we just need to put the ball stud on the backside. And this servo horn has a long boss on it, so it doesn't really have space for a nut, but you could trim that off. Brian put a blue nut on the backside, so I don't have that little detail. Now we're going to sit it in there, and you can see how the nose tube is in the way, but we'll use just a little bit of servo tape here because I will probably be taking this back out, and I knew that at the time, so I didn't want to overdo it. But that will hold it in place well enough that we can see how everything goes. And I'm going to position it in there as close to that nose piece as possible without hitting it and get it squared up. Now, this is one time where I kind of wish they hadn't put the etching or logo mark there on the chassis because it's mostly covered up, but not completely. And obviously wouldn't have been on Brian's car. Now, do not push down here on this ball cup onto the bell cranks. Put a tool. I like to use an L arm that fits underneath the bottom of the bell crank. That'll support the load, so when you push down, it's not going to brunel your bearings. And you have to push down pretty hard, as you can see there. So that takes all the load, puts it into the pan, and now we are happy. And that is working quite well. This is my original Team Losi Revolution Insane motor that I bought in the late 80s. $75. That was all the money in the world to me. And I know that this would not be the motor in Brian's car. I doubt he was running a Team Losi motor. But he did win the World Championship later on with Losi. So this is kind of foreshadowing that. Also, the pictures don't show the motor in his car. It had been removed already. But I'm super excited to get to put this little piece of my history on this car. And I'm going with it. It's not a big commitment. It could come back out. And getting the pinion on there with the right clearance. And we'll just snug up our screws once everything is correct on the backlash. And that looks good. And even though that's not a Hydra drive, it looks good. The motor looks good except for this lead. I should probably desolder the wires, but I don't want to, so I'll tuck it in there. And I'm super happy. Look at that. Now we have the cover here, which is sort of close to what Brian would have had, but not identical. Cut that little tab off. I'll pop this in here, go around the ball cup. But yeah, looks pretty good. In the pictures of Brian's car with the body off, he didn't have that dust cover on. This battery strap really looks like Brian's. Has a little angle on the end. And the screws he used were Phillips head. Why Phillips? I have no idea. But I'm using pan head screws, 1/2 inch length. And we're just going to put them into this battery box. And then your battery is pretty much going to be stuck there. But I guess that's the way he wanted it. So tighten those down, and then the strap really locks into place. Brian's strap says something on it. If anybody knows what that is, drop me a comment. Now we have the tire package, which is a little different than what Brian was running on his car, but obviously those would change. They've got the Team Associated logo on the front and the back. We'll go with them for now and just work those fronts over the wheel. They go okay, and they're kind of balloony. And so getting them to fit on there, you have to kind of work it around with your fingers there. And just make sure it's all sitting in the bead. I'm not going to glue these. I wouldn't run these tires. So the backs are stiff. You really have to pull on these. You got to tug pretty hard to get them over. So just keep working it, and then they will just pop into place. Then I will roll these a little to make sure that the foams have seated correctly. These are the right kind of tires for an old school loamy dirt track, so they got that right. Let's throw them on the car. Put your bearings in the front wheels. These are aluminum axle shafts, so just be aware of that. Do not cross-thread your nut. Normally, I would put a plastic nut there, but Brian's car used a metal nut, so I'm going to stick with that. I'm using aluminum nuts upgraded on the rear because that's what the original World's Car kit came with, and I can imagine Brian using aluminum there, and I just like it, so I'll do that, but very subtle change. Most people aren't going to notice that. And we're almost to the finish line on this mechanical build. And check out the suspension here. Looking good. We're going to put the wing buttons on the wire just because what the heck? They're nice blue anodized aluminum buttons. I don't know that they look exactly like Brian's buttons, but it's fun to do something unique. And the blue certainly matches the theme of the car with all the blue hardware. So I'll drop that into the wing tubes, and there they are. Brian used a red antenna tube, and it was bugging the heck out of me that mine was black. So I went and sprayed it with some bright red polycarb paint, and I'm happy with that. It wasn't that hard to do. Now, these body clips, I'm not using those black ones. I'm using vintage original clips here, and you'll see that these were in a unique location on Brian's car. I'm popping them on the posts first here, but this is where Brian had them in the pictures, just on the chassis there. And I think that is so cool, and they've got to be the right kind of clips. So that's what I've done. And let's take a moment to admire our work. So many little personalized touches that represent what Brian did with his car. It's just fun to look at and just discover all of those little changes. And my motor's there. I wanted to recreate this picture with our tribute car, and I'm pretty excited about the outcome. There it is again, and our car. What a beauty. This really was one of the most fun builds that I've had maybe ever. To me, adding all those special little extras just makes this more special. You have to truly discover Brian's car as you go through and make those upgrades. A lot of fun. And here are all the parts that I didn't use. Really not that bad, mostly hardware. I'll throw them into the parts bin and use them later. Once again, big thank you to RC10 Talk for providing the materials to make this build possible. And I can't say anything bad about this kit. I loved it. I think it's one of the best engineered, if not the best engineered, re-release kits from Team Associated. Everything went together really well. The instruction manual was decent. I didn't have any issue with it. So I highly recommend it. You can take this as far as you want with all the embellishments, or you can build it right out of the box. Whatever you prefer. Anyway, that's a wrap on this episode. What's up next? Well, we got a graphite to build, so if you're interested in that, we'll see you next time.